Hello folks, welcome back to EvolvNext, and we are in the Python for data science module, and our today's topic of discussion is data visualization. In this video, we would have a look at the introduction of Matplotlib and Seaborn library, and we will be performing univariate data analysis, wherein we would be doing an analysis for categorical and numerical data and plotting a few graphs like a bar chart, pie chart. Then we would also draw a histogram, the KD plots, then the box plot, and so on. So let's jump in. Now, what is Matplotlib? Matplotlib is a graph plotting library in Python that serves as a visualization utility. So for visualization, we would be needing Matplotlib as well as Seaborn library. Um, and they have a difference between both, which we will have a look at. So you would see first a few minutes we will be um, just focusing on a theoretical part which is essential to know, and then we will go on to draw some plots. All right, so a little bit of theory here, not a typical one, and that we straight away start with the program. So let's have a look what are all the components for Matplotlib library. So Matplotlib library was built on NumPy, and then something called as Pillow, Cycler, tkinter, latex, and pylab. So what it does actually, the roles and the component, I have try to put it together in the table. So it was built on all these components. Below, that is short form PIL, it was used for image processing. NumPy for numerical handling of data and array operations. Then there is something called a cycler, which manages colors and styles. Then tkinter, if you um, are aware of this, it's a GUI that comes with Python. All right, a GUI interface, and that comes with Python. And then there is something called as latex, which provides mathematical text rendering for plot titles. What is plot title labels, you will come to know shortly. Then there is something called as pylab, less common now because these days pyplot is used more. All right, then there are various different layers as well in Matplotlib. Like it's a user uh, there is a user API which provides high level plotting functions. These functions we will see soon. All right, when we draw those plots. Then there's a pyplot interface for quick plotting. All right, if anyone is familiar with MATLAB, it will just provide an interface like a MATLAB. And then there is an artist layer which actually helps you to plot elements such as lines, markers, text, whatever required. All right, and there is a figure layer, there's a backend layer, and those descriptions are listed down here. So not really going to uh, uh, put more time to read out these things, but yes, it was important to list those down. Now, how does matplot plot look like? All right, so there are a few components of a Matplotlib plot, wherein the high level component, or you may say, um, there is a base level component that is called as a figure. All right, so whatever you want to draw, everything would be drawn into this figure. Okay, and if you want to name that figure, then there is something called as super title. In that then after super title, you have got something called as axis, wherein you will be drawing those individual plots. All right, and there is something called as axis. Axis is what? Axis is nothing but your x-axis and y-axis. It's no different. All right, and then y-axis. Axis is just to name. Okay, sorry. Axis is where you draw all those plots. It will represent a particular plot. Now this, you would see, this is one plot and this is another plot, the red rectangle. This is called as axis. Okay, and then what are how will you name the x-axis and y-axis? With x label and y label. Then there is something called as major ticks, all right, and minor ticks. So axis, to divide axis into units, it is called as major ticks. To divide major ticks into some more units, you will call it as minor ticks. Then you would need to give a title to each of plot. So super title was common for all, and for each plot, if you want to give title, there is something called as title as a component. All right, then we have legend as well. So here you see in the green and blue color, this is called as a legend, and this is actually your lines or whatever you want to plot, those things. All right, so that's how you will be plotting out things. Then you might be thinking, Vishal, what is this pyplot? Pyplot is a module within Matplotlib, which provides interface for creating these plots and visualization. That's the reason you would be seeing we will not using entire Matplotlib library, because most of the things are covered in PyPlot and that module will be used. You would see when we code this. All right. Now let's have a quick look at what is Seaborn. Yet another library. However, it uses Matplotlib in the backend for plotting. Then why do we need this? It reduces number of lines of codes, and it also provides some fascinating themes as well. All right. So wherever suitable, we will be using Seaborn library as well. So all these libraries that Matplotlib and Seaborn doesn't come pre-installed with Python. As you need to import pandas, you will be also importing Seaborn as well as Matplotlib. However, you would be importing PyPlot module in Matplotlib, as it contains most of the things, and you have renamed them. You will be renaming it as PLT or SNS. That those are alias names. We are very well aware of these things now. Now, in this case, we have taken a sample movies dataset again. And we had used this earlier as well, and we read it. It's an Excel data set. We use read underscore Excel functions. I would not be explaining all this because we have already covered this. And let's just have a look at what all things it has it in data. It has got a movie ID, budget, popularity, revenue, title, vote average, vote count, director ID, year, month, and day. Right now, we are doing visualization, that is fine. However, our end goal is to achieve data analysis. Now in data analysis, there are different types of data analysis you do, or you say you do different types of analysis. One is univariate analysis, second is bivariate analysis, and then there is something called as multivariate analysis. Today we will be focusing on univariate analysis. Univariate analysis is nothing but analysis on one single variable. That is, maybe you want to analyze something on just only on this revenue feature or revenue column, you might say. Then if you want to analyze something only on title, a title column. So these are the things you will be looking into. You'll be analyzing, taking only one variable into picture. Now this also can be further divided into categorical univariate analysis and numerical, because the data is either categorical, that has got a fixed set of values. In the sense, you may consider a t-shirt sizes. All right. It will be small, medium, large, XL, double XL, for that matter triple XL. However, it's a fixed one. It doesn't go beyond that. Yeah, or and if you consider sales or profit, then it's continuous one. It may increase. We cannot define it as a fixed set of values. All right. So that is something called as numerical over here, or you may call as continuous. All right. So it depends whatever terminologies you use. So what I'm trying to do is, now taking the month into consideration, I'm trying to count the value counts for movies. How many movies were released in a particular month is my motive. All right. So I have created a movie count as a variable, and in that variable I'm trying to fetch month out of my data, and I'm trying to do a value count of it. Now you would see month occurs in the index over here. This one, 7, 12, 11, these are nothing but month numbers. Now the thing is, if you want to convert these numbers, month numbers, into names, like instead of 4 you want to write April or something, you may very well go with it. No issues. You will have to do some data transformation, and you will convert it into required format you want. Now this is in numeric format. So seventh month, that is July, 12th month, that is December, and so on. All right. And then what I do, I simply try to plot a graph based on that. Now if I just run this, you would see this beautiful graph here, wherein the months will be listed on the x-axis, and um, number of movies released on that particular month, released in that particular month, will be listed on the y-axis. So you would see in February, these many movies were released. In say 7, this is month 7. So in July it was maximum. In July and in December it was maximum. So you can make analysis on looking at the graph very clearly. However, here you would see why this extra line is getting printed. So if you want to eliminate this, you will have to simply do a plt dot show. All right, we don't need that line, right? So if I run it again, you would see here that the line got eliminated. Okay, and we just want that graph. So similar thing will appear over here as well. So okay, we'll see the output first, and then we will try to eliminate that. Now you may think these bars are a little thick. You want to reduce the width, or maybe you want to add some different color. All those things are possible. It's up to you to research on what this bar function does. All right. So for univariate analysis, categorical variable, we are drawing a bar chart. All right. This is the figure size that you can increase or decrease the figure size. Okay. Figure size is this frame size. You would the output you are seeing here. This can be increased or decreased. Okay. So you can try a number of things. There are a lot of parameters coming in with the functions. So I just run this. You would see this extra text being coming, which I mentioned earlier. So I will just write plt dot show over here to eliminate this text, and then we will be able to see a clear output. All right, without that text. Here you would see pretty decent width that we mentioned, and easily distinguishable um, easily distinguishable bars, and you would see the rotation of the ticks got rotated by 90 degree. If required, you can do it. Whatever rotation you want, you can do it. Now it is good that it's a number. However, if text is there and it mixes with some other text, then this rotation feature will help you, because you may rotate it and avoid the overlap or the mixing of the two names. All right. And same thing if you want to draw with the Seaborn. What we discussed earlier was Seaborn will reduce number of coding lines. Definitely it is doing. Look at this month here itself. You can mention the month data. You will mention it here itself what data you want to give, and you simply have to draw a plot using a count plot function. You're drawing a bar chart using a count plot function. So if I run this, you would get the same result as you were getting earlier. You can very well research how to add the color and how to reduce the width for this as well. Now, moving ahead, if you want to draw a pie chart, so just for the sake of, yeah, so just for the sake of showing it to you in the first go, I just deleted the outputs. Okay. Now, create a pie chart. We are trying to create a pie chart over here. Again, month and the value counts, same things we are taking over and over again, and month dot index, then these parameters, what is the start angle, all these things you have to mention, and you try to draw a pie chart. We have a plt dot pie as a function, and these are the parameters inside that. Whatever title you want to give, the title you should specify. Okay, then you put it as uh, uh, plt.axis inside that equal, so that equal aspect ratio ensures that the pie chart is drawn as a circle. So okay, then plt.show, the purpose of the plt.show, we don't want any extra information there to be displayed. Again, the months and the distribution in total number of movies, how many movies were released on month movies released in month 11, how many movies were released in month 7, and so on. So this is how you would have concluded that okay, that with this I am easily able to see that 12th month and 7th month is giving me 18.2%. That is the maximum percentage coming from these 2 months, and the least that I could see here is 3%. And I think there will be some 0% as well, because all 12 months are not displayed. So that's how the data looks like. So contribution wise, if you want to see, you would see it this way. So this is all about what categorical data. Whatever we had drawn till now, that is the bar chart or the count plot, or whatever it is, pie chart, it was for categorical data. Now say you have a continuous data. Again, you single variable, you were trying to do analysis only on basis of month, right? Count is something that you added. It is not the count is something that is not in the table. Okay, it's not a variable of the table. It's something that you added. You want to aggregate it on count and see. That's the reason you saw it. However, it is not a part of our actual data set. Okay, so we were doing analysis only on the basis of month. So these are various different graphs. These are various different combinations you can draw with, like reducing width, adjusting figure size, and all these things. So these are the basics of Matplotlib. And we also use count plot, which is there in Seaborn, to reduce the number of lines of code, and we were getting the same output. So it depends, whichever library suits you, you can use that. And looking at what is required to draw. All right. So some of the things will be available in SNS, some of the things will be available in Matplotlib, some of the things will be available in both. You will have to check accordingly, and you will have to draw those graphs. Now, for the continuous data visualization, that is, this is for the continuous data. like budget, revenue. These are continuous data, right? It is not something categorized. Okay. So again, you would see here we are trying to draw a histogram. Now, histogram for what? Histogram for budget. So if I run this, you would see budget is what I mentioned. I want the histogram to be divided into 30 bins. That's what I have done. Then the age color, some I have given the age color as black. That's why you see a black over here. And then distribution of movies is the title. Then X level, Y level, whatever you want to name, X axis and Y axis, and then PLT dot show. So simply you could easily make out high budget, which was the um, maximum uh, budget frequency depending on the parameter budget. So most of the movies were made in the budget zero point 0.7, around 0.7, and these are e raised to 8 something. So that is metric. Forget about the metrics. You may very well convert into the millions or whatever unit rupees, whatever unit you want, and you can display. That is not the part of discussion. All right. What we are trying to see is how we can draw the graphs. So you already know how you convert the budget or revenue into millions and then display it. Then it will look pretty nice. It will not show like this something e raised to 8 or something. All right. So that's a metric what you use. So it doesn't matter really. However, you can make out that maximum of the movies were in this budget. All right. And then moving ahead, we try to draw KDE plot, that is kernel density estimation plot. All right, wherein you would be seeing all the distribution, and um, it will be showing in the form of a curve. Popularity lies between 72 and 76, and it was peaking somewhere around 74. You may easily be able to conclude on this. Okay, so this is the density plot of popularity. Then we also will be able to draw a box plot. What is box plot? It show how the revenue in this case is distributed. So revenue is distributed this way. That is, it is maximum. It tends to be in the range 0.9 to say 1.7 or 1.8. Most of the movies have generated this much revenue that ranges between around 0.9 to 0.9 to 1.7. All right. Now, what is box plot? What all things are there? There are things on box plot, but we are not describing each and plot every plot in detail. However, I would just like to tell you, box plot provides something called as interquartile ranges, and you need to understand those. There is Q1, Q2, and Q3. What are those ranges? You need to understand. You need to understand what is median and all those things. So this is not a topic on discussion of each and every plot that we are drawing, but to understand the data and visualize. By this visualization, you easily understand that okay, most of the movies are giving me revenue around this range. So that is something important for us at this point of time. So if you want more information on box plot, you may very well search box plot, and you will get to know what I'm trying to convey. All right. So here, um, in this video, what we have seen is we started with the theoretical stuff of Matplotlib, and Seaborn. Then we went through the components that are there in the Matplotlib plot. All right, we went through each and every component. This is how it looks like. And then we imported Matplotlib and Seaborn. We saw what is PyPlot, and most of the things that we need to draw plots are available in PyPlot module of Matplotlib library. That's the reason we import only that module. Then we took movies dataset. Then we tried to do a univariate analysis. In univariate analysis also, we did categorical analysis and numerical analysis, because I mean, in a way you can say there was a categorical data, there was a numerical data. So for those, you need to draw plots accordingly. So for categorical data, we drew bar plot, we drew pie chart, and we draw a count plot. And for numerical data, we have drawn histogram and box plot. All right, and we saw how we could adjust colors, how we could adjust widths of the bars when uh, we had drawn the bar plots. And accordingly, we also saw how to draw pie chart, how to draw a histogram, how to draw a KDE plot, and finally a box plot. So thank you for watching. I hope you enjoyed this introduction and exposure to data visualization through Matplotlib and Seaborn. Moving forward, we will be jumping in to bivariate analysis and multivariate analysis, and have a look at which all more plots could be drawn with data visualization. Thank you for watching and see you in the next video.